Welcome back everybody to the security stream of the GSE conference. This is the second security session of the day, which is the title of Intelligent Dataset Level Encryption and Key Rotation. And we've got our presenters standing by on the in the call. But before we get there, just a couple of logistics. So for the purpose of feedback, this is session 1BC. So you've got the QR code down there. So please use that, or go to the agenda and give your feedback through there. And don't forget on feedback that the best answer to question 1 is 5, and then the other questions is that the best answer is 9. This session is being recorded, by the way, so if you are listening to this as a recording, then you can still also give us feedback through the GSE website, and that will be open for several weeks as we collect that. So without further ado, I'm going to hand over to our presenters. So I'm going to introduce you to the two Chris's, Chris Walker and Chris Taylor. We've got Rebecca and John, so they're going to kind of be doing a kind of a team effort, as it were, for this session. And Chris Walker is going to be keeping an eye on the chat for your questions, and he'll be interrupting presenters, you know, to ask, you know, put those questions forward. And please, it's so important that you do answer that, you know, put questions in the chat. If you're really dying to ask something, but you're too afraid to, you know, because it's an electronic forum, please don't. You know, everyone benefits from it, but you know, by sharing the knowledge, as it were, and by getting those responses back to those questions. So without further ado, team, I will hand over to you. Thank you very much.
Okay, thank you very much, Jamie. Good afternoon, everyone. Thanks for taking time to join us today. I'm Chris Walker. We've got the other Chris and Rebecca and John from our partners at 21st Century Software. I work for IBM. I'm an offering manager within the Zmanage Analytics, and I appreciate your time looking at this important topic that we're looking at, where we're bringing in analytics alongside to the data levels encryption and key rotation topic here. So obviously, being in the security track, you're very interested in techniques around encrypting your data. In this session, we're really going to be looking at using application intelligence automation to really make sure that you can implement data set level encryption, key rotation with little to no application disruption, helps you reduce the risk and challenges around that as well. So I am going to hand it over to Rebecca for the first part, and we're going to be talking, all of us are going to be talking through this session as we go through it.
Good afternoon, everyone. And for those of you in the States, good morning. And for those of you on the West Coast, rise and shine. So I do really appreciate everybody that's here today, including some of the speakers. Of course, there's the traditional legal disclaimer, as always with an IBM presentation. But let's for a second turn to the concept of the challenges that we're facing with the concepts of encryption, right? With encryption, we want to make sure that we encrypt the data set when it's best for the data. We don't want to do what some customers that we work with have done and then find challenging, is they take a bunch of data sets and they go to encrypt them and they wonder why they have a little bit of an issue. That's not the best process, nor is it the best way to go. So we want to help people understand that data needs to be encrypted when it's best for the data. We need to have insights into the usage patterns. We need to understand and identify data that's associated with multiple applications so that you can determine those and make sure you're handling those and have insight into those, so that when they're tying together with different applications, if you're choosing to use different keys, you're going to have to take that into consideration in that whole process. And additionally, we need to be able to have applications, we have to make sure that when we're doing key rotation, that the same things are taken into consideration, right? We need to be able to understand how that data is being used at that time and be able to have that insight. So knowing and determining how the data is being used and allowing customers to assign keys with the appropriate tools and with the appropriate analytics, it augments tools like EKMF and TKE, and it really does help with you to adopt the encryption that your company is wanting because of the audits and all of the different regulatory reasons that are around the whole concept of encryption. And of course, this falls right within the entire encryption portfolio and strategy, right? So many times customers feel that, well, we've gone to this full disk hardware approach, and what John will share with you and can do himself is, that's great, But someone like John Hogan, who will be presenting later, he can get right around all that, right? So we really want to get down to the data set level, and that's what is being suggested, and that's what customers and auditors are expecting. So how do I do that? How do I make sure that what John shared with me, which is the top, which is what your storage is giving you, doesn't, it ends up looking like the bottom screen here, which he can't read, right? And this is exactly the reason why we have to do and take that extra level of data set level encryption. How does data set encryption work, and how does it look without the combination of IZBR and ZDMF? Manual and time consuming. Think about it. I was working with a client and we were on the phone, and they were looking at the ZDMF product, and they were saying to themselves, and they were saying in the call, well, you know, we're going to have to work with the application people, and it's going to take us about a year to get all the analytics in place. And then they were talking about, well, how would that analytics stay current? And when what was shared with them is that doesn't have to be manual. There is a process, and that's the ability for IZBR to find out those dependencies. And we can figure out when the data sets are eligible for encryption, and we can determine the availability. All the things that they were noting that were part of a very manual process with IZBR and ZDMF get tied together so that you have the analytics and then you have the engine. And basically what we view ZDMF as the engine, because it's the tool that lets you do the hard work with the smarts of IZBR on the front end, saving you time and effort. And the use case around this is strong because no matter who we are, if we're in business, we're insurance, we're in some kind of audited, regulatory, customer-facing data that we have that customers might have, the number one thing that seems to be affecting organizations is we need to encrypt. And so there is a use case, there is a business reason, and there's a technical capability. And that technical capability for the analytics is found in the product IZBR. Now, IZBR, for the most part, is a resiliency product. It was developed originally for the concept of, I need to know my applications. I need to be able to understand how these data sets are being used in those applications. I need to understand its backups. I need to understand this plethora of things. Well, for our encryption concept, we're using only a small piece of the functionality. We understand how the data is being used. That's the analytics of it all. And that allows us to be able to give the information for the applications and for the pieces that the customer needs. We use something called an app table. We use SMF data. We have history and audit and all these other things around it. But by virtue of using this functionality, we're able to give the customer the information that they need. Now, using an app table and this common scheduling packages is important, because if you're really going to encrypt your data and you're going to assign keys, you need to truly understand how the business sees the application. So many times in conversations that I have, I get told, well, we're going to only encrypt this application. I'm like, okay, good. So how does the business see that application? That business sees it as Monday, Tuesday, Wednesday, application month end, application year end, application quarter end, and all the leads and feeds that come from all these other different batch applications. Because remember, batch is really, it's all about sequential batch. And batch is always the piece that's processing things through and making sure they get to their end result. Well, that's not as clean as you might think. It's also kind of funny to find out that a lot of data comes from on-demand jobs on the outside of the scheduler. And that's important for us to know too, because we need to make sure that when we encrypt and assign keys, that we assign it to the data intelligently and with all the data that's being used. So some of the information that we're going to give you in the real-time analysis component, all the green that's noted here, we use with our encryption capabilities, and we really help the customer feed all of this to our engine or the ZDMF product. So our historical SMF data we can use to populate the inventory. We could, for a baseline, and we have a little typo, we'll fix that. We also make sure that the data set usage is used. We need to understand those dependencies, and that's probably the first thing you're going to use the product for. You're going to be saying, okay, within less than a week's time, you can get all of the data sets, you can get all of the dependencies, and you can have these reports. And from then on in, they're managed on a daily basis. You can make changes. Your encryption project can go from, I figured out what I want to do with my dependencies, and ongoing still understand those changes as they happen. You don't have to re-look at everything. So it's a real valuable piece to help make sure that you're assigning the right data and the right keys. But, you know, to feed an engine, just like you would feed DSS data, you need to understand what that data is so that you can make sure that the engine, DSS in that case, actually backs up the data you want and appropriately. You don't push all the data through DSS. You'll bring your system to its knees because of the MIPS it will use. It's the same with Zdmf. You have to be smart about it. You have to be able to size it. You have to know its file type. You need to know, is it already encrypted? You don't want to re-encrypt it, maybe. Non-extended or extended, because the engine, Zdmf, can take a data set from non-extended to extended. You may choose to do that, or you may choose to encrypt it based upon the way that it sits. You have to balance the data set, its sizing, just like you would any other engine that's doing the hard lifting of what we're doing here, which in this case is encryption and key rotation. So that's a very high level. And at this point, I'm going to turn this over to Chris Taylor to show you a demo of how this is done. Thank you. Are there any questions so far?
Nothing so far.
Thank you.
Okay, good afternoon. Hopefully you're seeing a 3270 screen, and that will hopefully make us all comfortable. I was thinking just now, a year or so ago, we were all, or a lot of us were in Whittlebury Hall, so hopefully we can get back to normality by this time next year. What I'd like to do is home in on some of the pieces that Rebecca talked about. Now, she mentioned our application table. So what this is largely going to be is showing, you know, parts of the IZBR product as they are today, the IZBR product, as well as then showing you some of the ways that this can aid with the generation of JCL, for example, to feed Zdmf for the encryption piece. Now, the basis of what we use as input to know exactly what is production data, what is application data, is we use the scheduling product in order to be able to determine that. In our particular case, being IBM, we're running with IZWS. So this is after the generation of the application table. This is basically what it would look like. We work off of, from a resiliency perspective, we normally work off of starting jobs and ending jobs. But of course, we need to know all data sets. From an encryption perspective, we need to know all data sets that are part of a particular application so that we can make sure that they're being covered by the correct encryption key. So this is what it would look like if you are running with, you know, from the standard job that we use every day to pull in the data from the application table. And by the way, just we support multiple application tables, including homegrown. With a bit of work, then you know, to understand the formats of those particular output from some of those reports, we would also then be able to do that with IZBR. The application table in its simplest form could look something like this, where you just basically mask your jobs or have specific jobs involved there. And the key here for us is column 9, which shows us, for example, an asterisk shows us the start of the application cycle. And column 9 with a hash would show us that it's the last job in the application cycle. So that's where the basis of the data comes from. And what we can then do with that is we can then build our inventory. And that would, I'm going to use one of our demo apps, which is called INSCT. And in that, we have all the data sets that were affected within a particular batch run. So this would be, for example, you can see some of this is dated back to yesterday. And what we would do then is, I'm going to dwell on some of the status here that we have. From a resiliency perspective, we normally look at things from a criticality. So we say critical data sets for us are considered input data sets. So a critical 1 means that's a data set that was opened for input only. And a critical, if you have a status of 2, an exception here, that means it was a data set that was open for both input and output. From when we're looking at encryption, of course, every data set in the application is important, so that we make sure that we cover all of those data sets. So we have, for example, we have a delete, which means that basically the data set was deleted as part of the application cycle. And then a 4 says that the data set is non-critical and it's created as part of this application cycle. So we need to make sure so that everything is taken into consideration. Now you can see here there's kind of a standard naming convention of IZBR demo, but you also see, for example, that there's some TCP/IP data sets that are involved because there's some FTP jobs. So those may be pulled in as well. But of course, if you're encrypting the data sets in the application, you need to make sure that they also have access to the encryption key, because otherwise jobs will then start to fail. So that's why it's important to understand all data sets that are affected as part of the application cycle, because invariably what we find somebody says, well, I don't know why that data set's accessing, this particular application. And we hear that a lot, I think is a safe thing to say. Okay, part of what we also need to know from the analytics that we use is what data sets are using maybe from multiple applications. And of course, what that means is that if a data set is being used by multiple applications, then we need to make sure that that other application has access to the key as well. So in here, for example, we have, there's a bit of a busy screen, but if you look at the first data sets here, you'll see that lo and behold, the actual owning application is INSCT, but then there's also another app called DDA app, which is also accessing this. So what that means is, okay, the owning key probably, if you're doing it on an application level, would be whatever is assigned to INSCT, but you also then need to make sure that either individual jobs or a particular application is then associated with that. Now, typically, we've heard this from clients already who are part of the way into their encryption process cycle, is that the way this can sometimes manifest itself is the fact that out of the blue, a job's, the application's been running fine for months, and then all of a sudden a job comes in which is scheduled maybe every quarter, every half year or something like that. And that will then cause disruption because we then have to get everybody out of bed to work out, the application, and then get the security people as well as potentially management to say, are they authorized to access this data set? And that can be timely, can interrupt your batch process. And that's the kind of thing with the analytics that we're trying to avoid here. Any questions in the queue, Chris?
Not at the moment, Chris.
Okay, good. So I'm not sure how far the people on the call are in their encryption process cycle, whether they're at the beginning or fairly established with this. But I just wanted to show you very, very quickly what this might look like in JCL. So we're doing key assignment here through RACF in our particular case, or through your security system. And it can be as simple as this. There is no mention of a key label at all that we're going to be using. And so that would then still be assigned. And there are other ways you can either do it through the data class or through JCL, but the recommended method from IBM is to definitely allow the security system so there's nobody trying to color outside the lines, as it were. So here in its simplest form, this is a data set that has been encrypted, and it's been encrypted by zdmf.test.key1 in this particular case. One thing I would also like to show is that start getting used to some 213 add-ins, for example, and there's a lot of different reason codes to kind of give you an indication of what the problem might be. But this is something that there is a very good red book that I was using as reference a lot of the time when I was trying to set this up in the first place. So this would be an example of an application because it's running under a completely different user ID that does not have access to the key, and therefore that would need to be assigned before they can then access the data set.
So we have got a question, Chris.
Mm-hmm.
So the question is, it seems to me that building the access list for each encryption key is best done from an analysis of the access list of the generic profiles that it is associated with. Why would I need to look any further?
Kind of for the reasons that I stated, in the sense of, yeah, I mean, if it's all straight down the path of a particular application, that's fine. But I would also see it in this way, and maybe John's got a different opinion on this, that the data sets you may have way too much application access to particular data sets. And that would be my take on this, and so the analytics are actually going to show you exactly what is accessing the data. And that might be a time to review and say, why is this application accessing this data? So I would use the analytics rather than just using the access list, which may have been created quite a while ago. That's my perception on this, unless anybody else wants something to add something to that.
Yeah, well, what I would add is that if you're talking about the RACF access, I mean, the RACF profile is what has access to the data. The SMF is what did access the data. So I think what we're working on here is we're trying to say, like, what data sets are being accessed, what jobs are accessing this, and what user IDs may potentially need access to the key.
You also have to remember that we're encrypting data set based upon whether the data set is open at that period of time. We're doing what the engine needs to do based upon what the data looks like at the point in time that we're going to send it to the engine, to the encryption tool. And that is not gotten from the access list. You really need to have that from the SMF data. We're looking at the actual usage of data.
Okay. Any other questions, Chris, at this point?
No.
Okay. So one of the other things that when we build the data sets in general, we the way that this is done is, let me go back to my user Mac here. We generate a template here that is run then within IZBR using another process, use a combination of the analytics as well as decollect here to produce the list of data sets that require encryption. And this can be something that is run on a regular basis. In other words, when you're trying to do one particular application, if it doesn't pick them up the first time, it could pick them up another time because maybe it's not an opportune time to try and encrypt those data sets because they're in use. John will go more into the what Zdmf is capable of doing. So in this particular example here, we're filling in data set names as well as application names or group names within Zdmf. And we have the opportunity here to convert to extended format. One of the things we do in the process is we differentiate between data sets that are already in extended format and data sets that are still in basic format. The recommendation from IBM is to convert to extended format if possible, and then do the encryption. But recent APARs within IBM have allowed basic format data sets to be encrypted as well. In this particular example, and John will talk more about this, I do specify a key label, even though that is not the recommended method. That's more from a testing perspective. And then we provide a list of input data sets. And the way that would then look is that you would get a data set list, something like this, which is just a list of data sets. The accompanying JCL would be then in here, which would then provide from the template what the data set. So we have a group called ATM app here. As I mentioned here, we've got the convert to extended format and the key label also provided. If you decide you don't want the key label, which is the recommended method, then edit the template to say don't supply the key label as part of the JCL for encryption. Now, one of the things that we have here is we have something called cross app. Now, cross app is kind of, I'm referring to it as a fail-safe mechanism. And cross app will say, okay, these are data sets that are in use by multiple applications. So these are the ones where you want to be careful and make sure that you do have the correct keys assigned before you perform the encryption so that the data sets can be accessed. Now, again, this could also be an opportunity to say, why are these data sets accessing this particular application and therefore, or being accessed by a particular application, and therefore determine whether they need to be separated out or whether they should be encrypted at all anyway. So that would be kind of like, I regard this as a kind of fail-safe mechanism before you actually going ahead and encrypt the data sets. Okay. Scrolling down on my other screen. What I'd also like to show you briefly is a couple of the other reports that we have there. We saw some of the data sets that were being encrypted. We also detect data sets that have already been encrypted. In other words, this is a short list, but as your encryption journey goes on, you're going to see more and more in this list. Now they get excluded from being re-encrypted. So we do check to say, has a data set already been encrypted as we're generating from the analytics? And if the data set has already been encrypted, then it will be removed from the list of data sets to be encrypted. We also have other reports here that we can also customize within exits within the product to say, okay, these are data sets that are part of the application. But I can also exclude some of these. So you'll see here that the files have been excluded by a user exit. So in other words, yeah, I don't want to, for example, in this particular case, I have a couple of other applications called Daily and DB2. I do not want to encrypt these as part of this particular process. So I have reports that can do that. You'll see here it says no X. No X means non-extended, and then we have the extended version of these data sets as well. So that's how we can differentiate so that we don't do kind of extra overhead associated with trying to convert a data set to extended format in Zdmf that is already an extended format. Last but not least, what I'd like to show you is that we have kind of like an audit data set. Sorry, that's in one of the reports here. I didn't get to the right one, sorry, but early in the morning here in California. So we have an audit check. And what this is also used by the resiliency product. So this is actually telling me a list of data sets which be referenced by jobs not listed in the application table. So we've seen it, for example, in a lot of customer sites that they do sometimes put jobs into the system without having, without going through the scheduling product. And this would also be kind of like a last resort to make sure they say, okay, well, if there's data sets that are being accessed from outside the scheduling product, I want to know about that as well. Now, this is, as I say, this covers the whole gambit here of, if you want to focus on just on the encryption piece, you can do that as well. But for example, here I can see that the particular TSO data sets, sorry, TSO user IDs are accessing particular data sets. In this particular case, it's the JCL lib for IZWS. And those would then need to be taken into consideration, or saying, why are you trying to access that data set? That would also be something that needs to play into this. So that's actually all that I have to show today. And unless there's any other questions, I'm going to hand it over to John Hogan.
Nothing at this time, Chris.
Okay, good morning. I'm John Hogan. Let's see, are we sharing my screen properly? Say yes.
Yep.
Yes.
Okay. Yeah. So I work on the engine part of this, the Zdmf product. Zdmf is traditionally, it started its life as a, let's go from the current slide, get in the slideshow mode. Anyway, it started its life as a data migration product, and that's what it does. It moves data sets. And a couple of years ago, when IBM came out with DFSMS data set level encryption, they said, we're going to have to recreate all these data sets. To get a data set encrypted, you're going to recreate it, right? You're not just going to magically put it in RACF and the data becomes encrypted. So that was pretty a big problem for them in a way. They're like, wow, how do we, tell our customers, yeah, it's automatic, but we have to, re-encrypt them or recreate all the data sets. So we started working on Zdmf and getting it to encrypt data sets. Then they asked for converting to extended format, as we'll talk about. And then I like the last one, they said, well, now that we've got a data set in one key, we're going to want it on another key and on a regular basis. So, and that's what we call key rotation. So we're going to kind of go through those three things. So just to start the conversation here, we talk about, what kind of data sets are supported by data set encryption. So VSAM extended format data sets. That's the one type. Then of course we have sequential extended format data sets and basic and large data sets, basic and large sequential data sets. And they're being supported, it was brought up again, they're being supported mostly so that vendors and people who do EXCP type access can have encrypted data sets. They're really not, IBM's intention isn't that people stay with basic and large format data sets for their sequential data. You can't compress them. Anything that's new that comes down the pike for new technology is not going to be supported by basic and large. So it's a big push. And it was a surprise, I think, too, in the first year or two of data set encryption, when IBM discovered they have a lot of big customers that aren't extended format. And even though it's been out for 20 plus years, so we take care of that as well. Just to talk about Zdmf, the installation, it's an IBM product. It comes through Shop Z. It's a very small footprint. It's got 6 installation libraries, 5 of them contain the executable code. It's got your standard load library, and then some recs and some ISPF, and a SAMP lib. The only real requirement initially when you put it in is it must be APF authorized. The load library's got to be APF authorized. This point here is going away, or it's going to be optional because it was a point initially, but the Zdmf server has to have access to the encryption keys, and that's right now. We have an APAR that's open and that we're testing internally, and we've got customers that really don't want to give access to their keys to Zdmf to be able to do it. So we're going to get rid of that requirement. Zdmf address space. So Zdmf runs as a server. Okay, it's kind of, I call it, it's like DFDSS. It's the engine, it does stuff, but it does run as a server. You create groups of data sets, and Zdmf describe what data sets are going to be encrypted or rotated or extended format. And those groups, then you submit them to the server, and the servers run on any LPAR in your sysplex, any LPAR that's capable of doing IO to the data sets that are being affected. You want to run it over there. And here's just a little example of what the server looks like. Pretty simple proc. It's a GZD main. And you got your load library here. And this is a pointer. This is a parm pointer into the actual member that's going to do your configuration. So, and I'll show you a little bit about the configuration. Zdmf has this configuration data set, pretty much like a parm lib, input kind of thing. And it's got 4 main parameters. There's a couple of other ones that aren't very important, but just to get you going, the 4 main parameters that you want to work here is this subsystem name. So it's any available subsystem name on your ZOS system. You got a command prefix, and the command prefix is how you talk to your server. And that's the real important one. If you're using the TSO interface, you have that kind of embedded in your user ID in the parameters there. If you're using the batch interface, which is mostly what we use now for encryption, you have that in the batch job. So it says, this is the server, this is Zdmf server I want to talk to. That's the command prefix. Then you can also use that command prefix. I can enter console commands to figure out what's going on with my group or my data sets that I'm encrypting at the time with the Zdmf server. The other thing here we have here is the Zdmf database file. And it's really, to me, it's a communications data set as well. So it keeps the group in there, keeps the messages in there, it keeps the status of the group, and it keeps the status of the servers in your sysplex for the multiple Zdmf servers. And then the last thing we have here is this high-level qualifier for target data sets. Zdmf has, they're called target databases, sometimes we call them, or target extent kind of control files. And you get one of these, you get a 10-cylinder file allocated on any volume that is a target volume in Zdmf. And we'll talk about source and targets here as we come along too. Let's see if I squish this down. Hey, maybe that helps. So Zdmf servers, like I said, we run a Zdmf server on each LPAR. So this is just a little example here. We've got Zdmf running on LPAR A and LPAR B. We've got our communications data set in the middle there. You got your applications running on your server down here. You got TSO, console interface, and batch jobs. That's just a little pictorial of how it looks. And so I talked a little bit about the group, right? In Zdmf, the group concept. Everything is done with a group. And so what you want to do initially to create your group, that's where we go into the analytics. Right? We used to have people say, like, I'm going to do a group, I'm going to do all the data sets that start with this and this and this. Well, part of the problem with that is that you're not going to be able to find, you're going to find data sets. You can throw out a group of 1,000 data sets, and what you find is 700 of them, go right away, 200 of them don't, another 100 wait, because we do have this divert step where we need to stop the application for a minute. Okay, so for 24/7 type things. But what we find though too is most data sets have some sort of a usage pattern that says, hey, this data set is available to be encrypted at a particular time. There's a time frame when the data set is available. So that's what we do, the analytics up front, help us create the Zdmf group. The Zdmf group is then promoted. We take that group, that definition, we promote it into the database, we activate it. Activation goes through and looks at the source data sets, gets the keys, goes out to your the SAF security product, we'll call it RACF or ACF2, top secret, I guess. Anyway, any one of those products gets the keys, determines where the target data sets are to go, and it does that by looking at where the source data set would normally go. It calls your ACS routines. There's no changes needed in your ACS routines. Then it creates those target data sets and goes into this copy phase. Copy phase, it's copying the source data over to the target and encrypting it at the same time, or rotating it, converting it to extended. All of that's happening during that time period. And then we go here into the divert phase. Now in this first example, this is done with some analytics up front, and we determined that during the time that we were going to run this particular group, that the data sets were going to be available. So we've used this early data set complete option in Zdmf, and that says, hey, if these, it actually gets to the copy phase, and it ensures that nobody's been using the data sets, ensures they're available, and if they are available, it'll copy, it'll go to divert, and it'll complete. If for some reason one of them was not available, it would go into this next phase we're going to show. It's called mirror, but it would actually check and make sure that it's available. So this other way of using the product is what I like to say, we do it for 24/7 type data sets. The data sets that have very, very small outage time. And that's what we can do. We can do it in, I do 700 data sets in like 40 seconds during this divert phase. So for those, we've already figured out through our analytics that we've got these problem children data sets, right? And there's a lot of them too. I can, we'll say there's a lot of those types of data sets. But what we can do is we can schedule and manage the small window. So if we have thousands and thousands of cylinders, say, it's going to take an hour or so to do this activate, to do the copy, to do the mirror. We can sit in this mirror phase for as long as you want. And what we're doing there is your applications are active the entire time. I like to say, say you have an outage window here at 10 p.m. on Sunday night. You can start this at like 8 p.m. on Sunday night. You can get it to this mirror stage. You can make sure that you're in mirror. You've got your 1 minute window here of application downtime. You stop the files, and all you have to do is stop the files and close them. You don't have to bring down address spaces as long as the files are available. You can issue the divert command. The divert takes place, and we go through the complete. And if for some reason the window was changed here, and you can always suspend and start over again if you want, or you can also issue a divert retry. Divert retry, you can give it a number of seconds or minutes. You want to retry every minute to see when the files are available. And with this, you can also issue a scheduled divert. So you can put a future date and time on the divert. So that's kind of the overall, the phases of Zdmf. And we're going to run through all of them a little bit again here. So we're talking about the iZBR and the analytics. This is what it's done. This is done. This is how it's fed. So iZBR has been looking at the data sets, and like we said, looking at who uses the data sets, what application uses the data sets, but also what I like to call the data set usage patterns, right? Like how often is this data set used? When is this data set used? And when do we need to be able, when is the best time for us to go ahead and do the encryption? So we're going to go in and look at this Zdmf a little bit, the promote phase. So the first part of a Zdmf group, we define the group here. We've got all the little group control cards. Here's our source data set name in here. And we've created this group, the group ENCTWX02. This is the data set that we're going to encrypt, and we promote it. After we promote it, if we look in the database or into the product itself in the ISPF interface, we would just see that it's inactive. So it's been there, it hasn't been activated yet, and that's what a Zdmf group looks like from there. Then we go through this activate phase, and I said the activate phase, once again, we'll go out, we'll get your key labels from RACF, Or if you have in the user definition, which is this one, we're using the user definition because it's testing, so it's easier than defining a RACF profile. So we pull them out of there. Or if it's not in one of those two places, we'll go ahead and look at the data class, the SMS data class, so that we do the exact same search order that DFSMS does, right? DFSMS, when it's looking for a key label for a data set to be encrypted, it goes to your security product first. And of course, that's what we all recommend. You want your security product to be controlling which encryption key is used. If not, it'll go to JCL. And in our case, for Zdmf, it would go to that user definition, or it'd go to the data class. Then the other thing that happens during this activate phase is we go to, we create these target data sets. And they're a clone of the source data set. And we figure out where we're going to put them by calling your ACS routines as if we were allocating a source data set. So once again, there's no changes to your ACS routines. When we do create these target data sets, we use this little high-level qualifier that you've specified here, and it creates a target data set with kind of a group name and a timestamp. Details on what does the activate phase look like. We're going to say, hey, look, this is the data set to be included. This was the key label we found for it. We tell you the RACF profile. This was a specific profile that we found in RACF. This was the key that we got out of it. We're going to find the target volumes. We're going to allocate the target data set, and we're going to activate the group. Let's see, let's go on. So the activate phase is just what it looks like a little bit here from the activate phase. After you display the group, we can see the data set, we can see the source and target, we can see where it's located, we see the key label that we're using. And then over here, if we were to look at the target data set, do a listcat on it, we'd see that it's already got its encryption key in it. And we would, if we were converting to extended format, we would also see that the extended format attribute would be on in there. The copy phase, this once again, we're going through, we're copying all of the source over to the target. We're also monitoring at this time. We've already been monitoring IO and new extents. Any changes on the source are going to be mirrored over to the target. We're encrypting the blocks, and the CIs are encrypted during the copy phase. If right after the copy phase, if we have that early data set complete, if we've gone to IZBR and our analytics have said, hey, you're in a window where this data set's not being used, we go through there and you'll go through the early data set complete. It'll go into divert. It won't even go into the next phase of mirror, and you'll be done with the group. Now, if it's not, if it's more one of these 24/7s, you go into this mirror phase. And in the mirror phase, every IO that's going to the source data set is getting mirrored to the target. So once again, you can have your applications up. And I talked about here, if you looked at, if you looked at the target data set and you were looking for extended format or encryption, you could look at this suffix in there and you can see that it's being encrypted. Mirror phase, kind of like I said, this is mirror phase. We're a data migration product initially, and still obviously we're migrating data, but we're just kind of migrating it in place and encrypting. So your application's issuing its IO, the Zdmf IO monitor finds that, determines that it's one of its source data sets. The source IO goes over here, the target IO goes over here. And during this mirror phase too, I want to say, if for some reason you've changed your mind, you can suspend it. If for some reason we ran into some sort of logic error, we suspend and you don't know, right? There's no harm going on here. There's nothing going on here that you can't stop in this mirror phase. Then we'll get to the divert phase. And like I said, if you've done the analytics up front and you've determined that the data set's not at all in use, it'll just go through the divert phase on its own. If it is in use though, you'll get this. You'll get the divert delayed. It'll say, hey, this is delayed. This data set is open. You can use the panels within our product to show who is using it. You can then issue the divert retry if you want. And because you know that the application is going to come down in the next 10, 20 minutes or something, you don't know exact time, and issue divert retry, and it'll continue to retry. And then once the data set is closed and unallocated, it'll go through and do the divert. And the divert at that time is just switching. It's switching the VTOC, the BVDS, and the catalog. So after the divert phase, you'll look here, you'll see the encrypted, the source data set is now encrypted, and you got the key in there. I talked a little bit about this idea that Zdmf runs as a server, and you have multi LPARs in your sysplex. If you're going to need to bring down one of the LPARs, or an LPAR came down on its own, any of the remaining servers will start complaining. They'll be missing this heartbeat command, so they'll say that it's idle. So one of them has been idle. If you know that that server's down, you can go ahead and remove it. There's a command to remove it. So in this case, I'm removing TDM2 out of here because I know that it's down. And the other thing about that too is groups won't change unless the server has been removed. Groups won't move from phase to phase. So this is kind of a way of making sure that you've got all of your servers up, because we need to make sure that we're tracking IO, all IO from any active LPAR to the data set. Key rotation, and I am totally without a clock here, no phone. So if anybody needs to jump in and tell me I'm going slow.
You've got 12 minutes left, John.
Okay, thank
and
you.
And that's if we have questions.
Okay.
So that's what you have.
Okay, thanks. So key rotation, this is, like I said, we do key rotation. IBM first came to us and said, they want to rotate keys. And I change keys. I said, why would you want to change key after you've encrypted it? But there's a lot of audit out there. There's a lot of reasons that you want to do this. So the initial starting point of key rotation would be you would change your RACF. You change your RACF, then you rerun this rotate. We have a rotate parameter here. And in here, we're rotating from our existing key label over to key label 12. Conversion. So a non-extended to extended format, we do the conversion for you. We can convert and encrypt at the same time in the same group. We always have this little caveat here. There are some certain block sizes in vSAN. There's three physical block sizes that we can't convert. And with sequential, of all of the sequential block sizes, so you think numbers between 4 and 32,760, there's 17% of those that we can't convert. And the reason for that is that adding the 32 byte suffix on there changes the number of blocks that are available to fit on a track. So we physically can't put those, we physically can't put that on the track without changing the number of blocks, which means trying to change the number of blocks means each track would have a one less block, which is not really possible. So I'm going to get rid of my PowerPoint here and go through.
So while John is switching over, does anybody have any questions?
Okay, so we got my 3270 screen up now?
Yes, you do.
Okay.
So quick question, do you reinterrogate STB to reblock data sets that can be reblocked?
System determined block size, do we
You know what, for sake of time, is it possible to get back to you, Lenny, at a later date, and that way John can get through the demo? Thank you.
Yeah, so we're going to start with this one first. We just got a data set. We're going to convert it to extended format and encrypt it. So we've got key 11 here is what we're going to start with. We're going to go over and look at the data set real quick. So here's our current list cat, and we've got no encryption on it, and it's not extended format. And so there's the Zdmf group. Activate it real quick. And so we've gotten into activation already. We're into copy phase. We start to the move of the data set. This is, I think, about a 45 cylinder data set. We can see the, where is it down here?
So John, there's a question and I'm going to answer it. The TKE workstation, what we're doing has nothing to do with the TKE. So no need for DB2, no.
Okay, and then so we've moved it already. We go into our pending complete, which means that we're heading through divert and it's completed. So we go back here and listcat. And now we're encrypted. We're at key 11, or is the key 11 on us encrypted? If we look at our attributes, we can see that we're extended now. So we're just going to go back. I've got the same group, and we're going to change to key rotation this time. So we add key rotation. We're going to comment out the convert to extended, and we're going to change the key label over here to key label 12. And so this is going to re-promote that group. It's deleting the existing group, promoting it, going to use the same group name. I can flip back over to the product. I'll see that demo one's kind of inactive again now. Can look at the group, and we've got the rotate on, it looks like. So we're going to go ahead and activate it. So once again, this guy's going to go through that, the activation, create our target data set, go through picking up key label 12. He's going to rotate over to that. We go into the copy phase and the divert. We're already done. We've done the move. We've done the data movement. He's using the early data set complete because we know there's nobody using this data set right now. And divert. And we'll go back and look at this guy. And yep, now we're on key label 12. So that's just our quick demo for here. So we got time for questions.
Okay, we have 5 minutes left. If anyone's got any questions, please.
The SDB reblock data, Lenny, if you want to have a conversation further, we can have a call with you with the team.
Yeah, I'd have to stop and think about what
Hi, John. It was just something that I came across that was causing us quite a lot of difficulty because we found a lot of data sets were using half-track blocking as a result of SDB, and I found that by looking at there's an SDB bit in the DSCB. By interrogating that, I can simply copy the data sets with a block size of 0 and let them reblock automatically. Okay, I think you're probably doing your I/O block to block, so it's going to be very difficult to change that. When I say block to block, I mean physical block, so yeah. It's going to be very different. You're working at a lower level, right?
Yeah. But what we've also found with system determined block size, and that is what you're looking at. Either variable blocked, it really only would work again, or would have a problem with variable blocked or undefined, right?
What I found was that there were a lot of data sets that were using half-track blocking that were did not have the reblockable attribute, the SDB bit set. Probably because people have simply used ISPF 3.2 to copy to copy the attributes, and it unfortunately doesn't copy that bit. So I had a lot of data sets that were half-track blocked, and when they moved to extended format, they went effectively to double the size because there was only one block per track. So something I want to talk to IBM about. Anyway.
Yeah. Yeah, no, I agree, but that's kind of using the higher level IBM.
Yes. Yep.
We don't run into that problem. We don't run into that problem because we are below. The only time we kind of run into it is with anything with a PDSEs where the block size has already been pushed to the maximum of the track.
Right. Yeah.
So
Okay.
yeah, it's pretty rare for us to run into that with PDS and some variable block, and that would be dependent upon the record length again. But But yeah, I understand. Yeah, that you would definitely see that in using like not DFDSS, but yeah, IBGener and higher level utilities.
Well, I was simply using ECAM's repro. The other thing is, how are you handling dataset names? Because one of the issues I hit was I looked at my first application and with shock horror, they have dataset names of 44 bytes. They were GDGs. It was when adding the GDG suffix, the dataset names came out at 44. I mean, do you have some mechanism for handling that type of thing when you've got to create a different name?
Oh yeah, we don't. Yeah, we don't. That doesn't affect us at all.
Doesn't affect you. Okay, right.
Yeah, not the Zdmf engine. No.
I thought you were creating a new data set for the copy you were doing, but is it?
It's a generated name based on that target high level qualifier.
Okay, right.
Yeah. So. Yep.
Okay. So how do you ensure that you have the same RACF access if it's a generated name?
We don't need RACF access.
But the data set itself, I mean, for example, if your system goes down, power cut, for example, you're going to leave those data sets lying around there with a different data set name.
The data sets will be under a high level qualifier of our target. So if their system went down, they would just delete all those target data sets. They're garbage.
Okay. All right. So they're effectively protected under a different high level qualifier.
Yeah, exactly.
Right.
Yep.
Okay.
Yep.
Gotcha. Right.
Yeah.
Okay.
So like all of our target data sets are protected under that high level qualifier. Only the Zdmf server has access to that, and yeah, they can delete them. So
okay, I'll butt out now and let somebody else come in.
No, great. They're great questions. Thanks, Lenny. Any more questions from anybody?
And John,
sorry.
Go ahead. I wanted John to make sure I was correct on the trusted key entry workstation, the TKE. We don't have need for TKE, and we don't have the need for DB2. That is true.
Yeah, correct. Yeah. Trusted key entry is the way you manage. So I'm totally out of my realm in this, but it has to do with the way you manage your master keys on your LPARs, right? When you go to encryption, you have these master keys, which are very important. I work in a test environment, so I can trash everything and recreate them, but master keys are this amazingly important thing that if you lost your master keys, you would just be, out of luck. And so IBM has this TKE workstations, and they have remote things, and you can, it takes 3 people to set a key, right? There's a beginning, a middle, and an end of these master keys, and you're supposed to have 3 different people with them in 3 different locations. So yeah, TKE takes care of all of that kind of stuff. It's way it's the initial part of just making dataset encryption available within your ZOS environment, and it's very important.
We're at the top of the hour, so we're probably going to have to finish here.
Yep.
I, like most people, have my next meeting to go to. So I really appreciate everybody. So thank you very much. I'm going to drop it this time, and I appreciate you all attending. I hope this is something we can do with you and talk to you further about. Thank you.
Yes, thanks everybody, and I'll just wrap up here. So yeah, this is thank you so much to the 2 Chris's and Rebecca and John for taking us through that session. It was really great. I did have one quick question, just out of interest. So, what is the uptake these days in, would you say, with customers around dataset encryption? Because I'm thinking like all the different requirements that we have upon us now to encrypt data, and I'm just interested to know what sites are doing.
It is increasing tremendously.
Okay.
Over the past 6 months, we have seen a serious uptick. People have gotten to the point where they realize that their storage methodology is not enough, and auditors are getting smart. So especially, I can tell you for here in the States, there's tremendous amount of presentations and a lot of things that we've been doing. The interest is there, and we're finding that people have audit fines and they're having to get them done by next June, next December. And so the speed, and that's where the analytics on the front end of Zdmf has made it easier, so that it's easier, more streamlined. So it's increasing.
Okay. Thank you, Rebecca. So, yep, that's it, folks. That's the session 1BC. Please don't forget to give your feedback. Go to the agenda and click on the session, and go straight to the bottom of where the past the synopsis, and you'll see the link there to the feedback. And it's important, like I say, not only for the presenters, but also for us as GSE committee to help sort of shape the future conferences, but also for you, if you're collecting CPE, CPD certificates, and you want the points, then you'll need to make sure you give your feedback. So please do that. Just a final word. So we've now got a short comfort stop until 1:30, that's GMT, and up next on the security stream at 1:30 we have a session. It's called I Smell a Rat, a Linux forensics approach. That's with Christian Korocki, and you might be thinking, well, I don't use Linux. Well, if your mainframe shop is running Linux on Z, then you might want to attend that session. So I hope you can join us for that. And once again, a big thank you for our presenters. Thank you for getting up so early from our American friends. It's been a great session, and goodbye, everybody. Thank you.
Thanks, Jamie. Bye-bye.
Thanks.